Alright troops, welcome to Practical Maintenance, and in this presentation I'd like to talk about dry docks. This will hopefully be of interest to people that just have an interest in shipbuilding and dry docks and traditional British industries. It'll also hopefully be useful if you maybe work in shipbuilding or dockyards. You'll get a better understanding of maybe what goes on behind the scenes. And if you're working in the department that's responsible for these things, it will hopefully give you a better understanding of how they operate. So if you're from any sort of big city in the UK, maybe even some small towns, coastal places, things like that, you'll probably have dry docks. These obviously were when Britain was sort of leading in the sort of industrial revolution. They were getting built everywhere. And there's a lot of them that are in disuse, in a sad state of repair. You probably walk past them every day. If you're working in these places that are still on the go, the chances are you still don't actually see how the gates operate. So we'll go into a little bit of detail on that and how they work, and hopefully next time you're walking past one you'll have an understanding of how they operate. I'll also maybe tie this in a little series of videos of maybe a virtual tour of some of Britain's biggest industrial cities, just to have a wee look at what you see if you were like driving or sailing up the river, driving by, just to see what you actually drive past or sail past every day and you don't notice. But that's for another video. So anyway, we'll discuss operating dry docks, and that's more so the basic principles of what they're there for, what mode it's in, wet or dry. Go into more detail on the types of gate you get, the gate operation, and then we'll just cover some other things at the end. And as always, if you've got any questions or anything you feel that I've not covered or isn't accurate, do leave a comment and I'll get back to you. So what's a dry dock? Well, from a very basic drawing here, you can see it's basically a big cutout that you can put a boat into or a ship into, pump the water out, and you can then work on the ship. It's usually separated from the body of water with some kind of gate or locking mechanism. So how's the dock filled? Well, if you dried the dock, then obviously you need to fill it to get the gate out, get the ship in, and it's usually done by flood valves. Now I've tried to represent this here. You get different variations of it. So you can have ones that connect through the dock side to from the body of water to the dock, and you just open this valve. Some docks will have a valve either side just to let you flood up quicker. In this case the valves are closed. Now these valves can be operated manually, or I've seen them operated with hydraulics as well. So I've seen ones that's just a big hydraulic cylinder that opens and shuts a valve. Other ones, it's like a screw mechanism which is done manually. And both have their pros and cons. When it comes to the dockside valves, you could argue of course there's less to go wrong with a manually operated one, because you're just relying on manpower, and as long as it's well maintained there shouldn't be any issues. But again, you might need more bodies on the job to do that, whereas if you had a hydraulic one, really it's just a control switch. But of course there you have the risk of any hydraulic leaks, contaminating water or power failures. You can't close the valve. So they have their pros and cons both ways. So charging a dock, basically you open your valves, and as you can see the water comes in from the river into the dock, and then once it's equalised you would close the valves. That's it. Wet, or this situation is a wet dock, valves closed. So you also get gate mounted flood valves, and again I've seen these with a manual and a hydraulic version. My preference is definitely a manual version. I've seen it's just so much more simple. You have you have a key, and you basically turn the key at the top of the gate, and that opens and shuts your valves. I've seen more modern gates where they've changed the manual operation into hydraulic operation, but it then involves running out hydraulic hoses and connecting them up and undoing 20-40 bolts on the gate to open up a watertight compartment to put the hoses in, to then open the valves, which you then need to remove the hoses once the valves are open, then close these plates again to then lower the gate or take the gate out. It's just, for me, it's a lot of work. It's there's no saving in time there or efficiency, and there's a lot more to go wrong for me. If you're ever getting a new gate, I would say keep it simple, get manually operated ones, especially on a winch gate, which we'll discuss later. So again, here you have your flood valves open, water will go in through the gate into the dock, and then once your dock's filled, close your valves again. Simples. So, wet or dry? So you'd have a wet dock if you're perhaps testing ship systems, testing the integrity of the hull, or carrying out some repair works that don't actually require a dry dock. So you might be testing pumps on the side of the ship. You might be running the shafts to see how they run without the actual propellers fitted, just to see everything's up and running, things like that. Testing integrity of the hull, make sure the ship's watertight, and just general repairs. You might need to put the ship somewhere that could be tidal, and at low tide the ship would bottom out, so you can just put it into a wet dock where the water level's maintained, and you don't have to worry about the ship hitting the bottom of the river, things like that. So in a dry dock, well, that could involve the ship's getting built and it's ready for fitting out, so it's been launched and it needs to go into dry dock for continued work. So they could be installing more machinery, installing the shafts, the propellers, rudders, things like that. It could have been damaged and needs to go into dry dock for repair. It could be due it's a refit where it's just going in for some maintenance, or it's maybe just getting inspected. You could be just checking the hull to see if there's any damage or any corrosion and things like that. So let's talk about the gates. So these are the common types of gate that I've seen in dry docks. There's one type of gate I haven't covered, which is your chevron gate. Now, if you're familiar with the UK canal network, you'll probably have seen these gates. As the name suggests, it's a chevron, a V shape, and they just open and close once you're moving your narrow boats between your locks. I've not really gone into that because it's more focused on your bigger dry docks here. So a caisson or floating gate is basically a floating tank that's flooded up and sunk into position to seal the dock, and then it's pumped dry to float up and open the dock. So it's usually moved into position with capstans and winches, or a tugboat. Sometimes it can be a combination of both. And then you've got your winch operated hinge or flap gate. Now this is again a system where it's maybe a bit more complex machinery involved. You'll have a large winch and a system of pulleys to lower the gate down into the river, and the gate itself will be hinged at the bottom. So again, there's pros and cons to each gate. Your winch gate might be safer, need less manpower to actually operate the gate, but in turn, they're a little bit more complex and require a bit more maintenance. Both have their pros and cons. So let's talk about a caisson gate. So I've tried to illustrate here. Again, we've got a flooded dock here, water level equal. So a little bit more detail here. The little yellow circles represent capstans, and basically you would attach winches or wires to the capstans, and you would use them to twist the gate and twist it round so it's parallel with the length of the dock. As you can see, the flood valves on the gate are opened to maintain an equal water level between the river and the dock itself. This is because if obviously a river being tidal or the sea being tidal, if the water level isn't equal, the gate could jam, or you could have a sudden release of the gate, and it could spell disaster. So if you've got a caisson gate, you do need to make sure your flood valves are open, whether they're on the dock side or on the gate themselves, just to make sure you're maintaining equilibrium. So once the gate's been twisted round, it'll either get pulled out of the way by a winch or a tugboat will be attached. So as you can see, this is it rotated, and quite often there's a little notch on the dock side where the gate will be moved to, or if it's going to be a quick changeover, it might just get taken out into the body of water and then returned once the ship's been docked. So move to the side here. As I say, some areas do have an actual notch, so you might want to keep the dock just open, so you just park the gate up in the little notch area and tie it off and leave it. So your other gate's a winch or a flap gate, and again you can see by my excellent drawing here, it's not really terribly accurate, but you'll just have basically a large winch and a series of pulleys that attach through the gate, and when you want to lower the gate, you'll just start to lower the winch. Now there's a bit of variation with some docks. Some docks gates might require equilibrium, so you have the flood valves open as demonstrated here, and when you start to lower the winch, the weight of the gate will just lower the gate down and help it lower down on the pivot. Some docks, I believe, require a little bit more water in the dock than the river, so that this little bit of body water helps push the gate down. So it's important to find out what actually your dock requires. So here's a little bit of a closer look here. Now I've tried to illustrate the front here just alongside the white wire. You can see sort of bubbles. That's some gates will have a purge system that's compressed air, and that's basically just to try and clear any sludge or anything like that, debris away from the hinge and from the front of the gate, so that when you're lowering the gate down, it doesn't jam up, things like that. So as the gate's lowering, you can see obviously it starts to extend out into the body of water. It does depend on the configuration of the dock. So obviously this dock design, I would say, was meant to be a dry dock, so that once the water's pumped out, that the greater water in the river actually pushes the gate closed and helps it seal. So as you can see, it's going down, fully down, and it would just rest on a plinth under the water, and you can take your ship out. So when's it a wet dock and when's it a dry dock? Are they both the same? Are they both different? So let's look at this dock design here. This is a side view. You can also see I've illustrated the dock sump here. Now that's where your pump inlets will be for pumping out the dock. I won't really talk about that in too much detail, but obviously if you want your dock to be dry, you need a little area where water will run lower than the dock floor itself, so people working there have a safe dry working area. So your dock sump you'll probably have larger dewatering pumps for taking out the majority of the water, and then you'll shut these down and go to smaller pumps just to get the last remnants out. So in this example, you can see we've got a dock level higher than the river level. So what that would mean is obviously the water pressure would be pressing out the way towards the river, just as you see here. Now this is where designs, you need to pay attention to the design of the dock, and you can't always use every dock for both functions. So in this scenario, you've got water in the dock, but the river level is higher, so it'll still push against the gate and push it into the dock. So just looking from a top down view here, if you've got a dock that's solely built as a dry dock, then it should always result in the gate being pushed in, and this is because you'll have sealing faces on the gate. Now it's like any flange or anything like that, you'll have a sort of rubber seal, and ideally you want the pressure to be pushing against the seal for it to work. So in this case, if you look at the design of the gate, you've got the black rectangle of the gate, and it's sitting in a kind of notch in the dock side. So if you didn't have the notch on the outside in the river as well, then this could only function as a dry dock. So again, just a little bit of water in the dock here. So if you're wanting to use a gate like this wet, then as you can see here, because it's in a notch itself either side, this gate would have a seal on both faces, so when the river level is higher it pushes in and seals on that face, and when the river level is lower it'll push out and still have a sealing face to mate with to hold your water in the dock. So as I was saying, the considerations we have to take into account are you've got to have a gate that's reversible depending on the dock mode. So sometimes as well it could be a case of the gate only has a seal on one face, but you would actually turn it around and put it inside the dock and it'll have a sealing face on the dock, rather than a gate with two sealing faces. So that the demonstration we've seen there was a gate with a front and back sealing face, or you can have a gate with a locking mechanism. So I've tried to illustrate a locking mechanism here. So you can see just at either end of the gate on the river side, on the left hand side, I've tried to do a couple of lighter grey pins, if you like. Now basically what I've seen here is you'll have these pins that will either extend outwards and just hold the gate in against its sealing face, or you can have ones that maybe extend downwards and vertically and just lock it in place. If you're using a gate with a wire or a winch gate, then it's important that you'll pull the gate tight with the winch and then you'll put your locking pins in. It's important to slacken the wire so that the wire doesn't get stretched and damaged, because at the end of the day your locking mechanism is meant to hold the gate in place and keep it sealed. So how do the gates work? So here's an end view of a dock gate with your inbuilt flooding valves. And basically it's just a sluice valve or a gate valve, and sometimes butterfly valves, but it's just you just open these. Now you can either open them from the top of the gate with a key manually, or they could be hydraulically powered. It's that simple, it's not much to it. If it's a hinge gate with this design, then basically it's just obviously a penstock through the gate to the valves. If it's a floating gate, again it's just you'll have a pipe running through the gate into the sealed with the valves. At the bottom I've tried to illustrate with rectangles. Your gates should have some kind of sacrificial protection on them, so it could be like zinc blocks like that, and obviously they're designed so that they corrode before the gate, because your gate will cost hundreds of thousands if not millions of pounds. You don't really want it rusting on you. So that's something when you're maintaining gates, always make sure they get renewed at the correct period, and if you're inspecting it, it's something to check. Here's just a basic sort of square, I mean nothing to it really. So what's inside a casing or floating gate? It's simple, but it could be quite daunting if you're being told to move this for the first time. So this is just a floating gate. I've not illustrated any dock flooding valves on it or anything like that. So you could assume that this is let's just assume that this is a gate that goes into a dock where the flood valves go through the dock side rather than the gate, for simplicity. So you see at the bottom there's two gate flooding valves either side on the main tank, and then you'll see a little valve either side connecting the main tank to the wing tanks. You'll have your pipe work going up through the top into the control room. You'll have a suction inlet, a valve, and you've got discharge valves going to the wing tanks or to the dock or river, and obviously there should be a pump at the end of the inlet, and this is how you get the water out of the gate, and your flooding valves obviously so you get water into the gate. So let's just have a wee look at a side view here. We've got a casing gate in position in dry dock. So you need to open your flood valves equalise the water levels either side of the gate. And this is the gate now ready to be floated. And again, if you've got any locking mechanisms, now's the time to remove them. So inside your sunken casing gate, your gate flooding valves need to be closed, and you'll basically start your pumps, so you're just pumping water from the main tank to the dock or river, and of course your wing tank valves need to be open. Just a little word of warning, I've been in some gates where you need to close the wing tank valves because if there's a hatch or a cover on the control room to the main tank, the higher water level in the wing tanks wants to equalise and flood the control room. So these valves might be closed, so you might need to make sure they're open before you start pumping. And also as well, this is to make sure you're not creating a vacuum or anything like that as well. So again, here's just another illustration of the valve set up to discharge the gate. So your flooding valves are closed, your wing tank valves are open, and your pump, suction and discharge valves are open. So what happens is you'll start pumping water out the gate. After a period of time, the gate will begin to rise, and then once it's fully extended or fully floated, it's just a case of we use the capstans or a small tugboat to get the gate out of the way. Simple. So to sink the gate is basically just the reverse of that procedure. You move the gate into position and you open the gate flood valves and you start flooding the gate up. So this is obviously once the gate's flooded, we've also configured it to pump a little bit extra water in to the wing tanks, but as you can see the wing tank valves are closed. This is just obviously if we were pumping water into the wing tanks with the flood valves open, then it would just keep cycling round depending on the river level because there's nothing to hold it in position. So keep your gate flood valves open, close your wing tank valves, and then just top up the ballast until you're satisfied or you meet the requirements laid out in your instructions. So just some additional maintenance then guys, like obviously ensure your pulleys, valves, ropes and things like that are all in good working order. You should have a good maintenance procedure in place for greasing things and checking them periodically. It's also good practice to you know, if you've got valves that aren't going to be moved for a couple of years, there should be a process where you're moving them every maybe 3 to 6 months to stop them from seizing up and keeping them lubricated, things like that. I've seen it on many occasions where you guys haven't touched a valve for 3 years or something while ship's in a dock, and then you go to move it and it's absolutely solid. So it's a little bit of work on the short term, but you'll get a long term benefit out of good maintenance. And yeah, so that's it guys. If there's any questions, please drop a comment, I'll get back to you. I think it is a fascinating subject, looking at our industrial heritage, and as I say, I'll try and do a wee virtual tour soon, and we'll talk about some of the things you actually probably walk past every day and you don't notice, and we'll talk about them a little bit more and just give you a little bit better insight into what's going on around you. Anyway, I hope that was informative guys, and thanks for watching. See you soon. Cheers.